Okay, we're ready to kick off again now. So I'll hand you over to Jason Wright from Google.
Am I on? Yeah, I am. Excellent. Hi there. So as you said, I am Jason Wright. I am an SRE with Google. I've been with the company for a long time, about 8.5 years, and I've got the opportunity to see how our infrastructure has grown and changed over time from roughly unmanaged to varying degrees of management. Right now, I think we're in a pretty good state. I am pretty firmly an ops guy. I've been doing just traditional system administration, mail servers, DHCP servers for a long time. I'm being drugged kicking and screaming into the brave new DevOps future. I'm not entirely certain it's a good thing, but I can tell it's where it's going, and if I want to keep working, then that's what I'm going to need to do. I was originally going to just discuss how we worked with the Puppet manifests themselves at the kind of scale that we have, the number of nodes that we're running. And as I was preparing the presentation, I realized that Puppet is actually matured enough in our deployment. We've been running it about 5 years, that it's become another just core infrastructure service. And in some ways, it kind of just sits along our internal DNS and DHCP and print services. And so I thought it would be good to discuss some of the nuts and bolts of the deployment, like how we're doing things, and some better ways to work, and some of the things that we found that work with our deployment of Puppet. So there are a lot of things that I've been hearing here that are all good things, a lot of DevOps best practices. I'm not going to talk about any of them. We do them all in one form or another, and they're all great things, and you should do them too, but it's not what I'm here to talk about. And the first thing I really need to get out of the way, it makes my PR people really happy, is that Puppet doesn't manage any of our public-facing infrastructure. Whatever your favorite Google service is, doesn't matter. If end users out on the internet can touch it, it's not run by Puppet. We have our own infrastructure that does that. It's all developed entirely in-house, and I can't say a word about it, so I'm not going to. So originally, Puppet was deployed by our operating system teams internally. The Mac Ops group deployed it first, and that was about 5 years ago. Our Linux team deployed it on Ubuntu. It came later. When I hired in, there was essentially nothing that managed our engineers' Linux desktops. You installed your machine, and then you were basically on your own. Not very long after I hired in, we rolled out a Red Hat 9-based distribution that had some homegrown scripts. That was better, but those scripts were not very good. They were not very extensible, and that OS, it was okay. It worked, it solved the problem. We then moved to Ubuntu. We picked Ubuntu because they had the LTS release schedule, and it was published, and they promised to adhere to it. At the time that we did that, Debian hadn't done a release in a couple of years, and we had no idea when the next stable Debian release was going to come out. And we didn't want to deal with constantly changing. Like, we wanted a baseline operating system that we could work with that wasn't going to change out from under us every day like testing was, or Debian testing, that is. So we released our first managed Ubuntu release was done with Dapper, and it was done with CF Engine. And we being the ops teams that were deploying this Dapper distribution, did not like CF Engine at all. It seemed like anytime we needed to do anything that was the slightest bit complicated, anything that was the slightest bit outside what CF Engine was set up to do, we ended up having to write shell code to do it, and it didn't seem much better than just having some homegrown shell scripts. The first release that we did with Puppet was when Hardy came out. And we also switched to a 64-bit architecture at that time. And I joined in right about the time that Hardy was almost ready to be released. We've had the Ubuntu team owned Puppet for a while. While it was with that team, it's when probably most of the manifests were written, or at least the size of the manifests grew the most. And during that time, we had a lot of churn in the team. A lot of people coming in, a lot of people leaving. Some people would come in and barely touch the manifest at all. They'd write maybe 3 lines. And then some people, like myself, would come in and write 10,000 lines and then leave. So now after about 5 years, we have all the problems in our Puppet manifests that any large code base has when it's had a lot of headcount churn in the developers and is using a rapidly evolving language. So now, as I said, Google is basically an infrastructure service. It's run by one of our SRE teams. That would be my team. We focus primarily on traditional IT services, and we try and run them in a more DevOps style. We provide file and print and DHCP service and things like that. And Puppet is just one of the things that we do. Kind of ironically, back when the MacOps wanted to roll out Puppet, they offered the job to me of rolling out configuration management, and I declined it. I was interested at that time in learning what it took to ship a Linux distribution, so I joined in with the Ubuntu team, and I project managed one of our internal server releases to a release, and that was a lot of fun. And in the course of doing that, I wrote probably 25% of the Puppet manifests that we had at the time. And so because I was so involved with the Puppet manifest, I became the secondary owner of the service. And then eventually, the Ubuntu team decided that they wanted to get out of the business of running core infrastructure services, which wasn't really their mission. Their mission is to provide the operating system that runs on the engineers' desktops. It's not to run apt. It's not to run Puppet. It's not to manage the Pixie servers. It's not to manage the TFTP servers. It's not to do any of that. So when all of those services left the Ubuntu team, then I left with Puppet and went in and joined the SRE team that I'm in now. So currently, Puppet is a stable service. It's in maintenance mode. We don't roll out we're not scrambling to roll out new features. If there's something that we need, then we do it, and it's great. But otherwise, we just let it run, and it does its thing. I do not work on Puppet full time. I would estimate that in this quarter, less than 25% of my time has been put into the Puppet service. I don't write manifests anymore, except the manifests that we use to deploy Puppet itself. And again, the service is stable. I hardly ever have to touch anything. And it's supported by our regular on-call rotation alongside the traditional IT services that my team supports. So unfortunately, I can't tell you how many nodes we have. We have a lot. When I took over the Puppet service, we were the largest deployment in the world. I don't know if that's true anymore. I haven't followed along with who's running how many machines. We're probably still top 10. We still have an enormous deployment. It's kind of interesting. I've been hearing a lot about the deployments that people are running here, and it seems like the typical Puppet deployment for somebody sitting at this conference is a cloud deployment. They're running, they want to deploy an application stack using a cloud computing platform. And that is not what we do, not at all. Our primary goal with Puppet is to provide the engineering workstations that sit under people's desks and to provide the laptops that people use to get their work done. It's just, we provide the base OS, and pretty much that's it. In the base OS for engineering workstations, we consider the compiler tool chain and the things that engineers need to write their code to be part of the base OS. So I guess in a sense we deploy some applications, but not in the sense that I'm hearing talked about here at PuppetConf. We are overwhelmingly on physical hardware. I did the math last night. We have less than 5% of our deployment on virtual machines. Those would be our internal IT servers, and we're 5% servers, and some of those are physical hardware, so something less than 5% of our Puppet nodes are virtual machines. And the others that I've got listed up there, I don't think we've ever talked about them publicly and what they're doing, but we have some small teams that are providing internally applications in a more traditional sense. They're providing an application stack on top of a base OS. So we don't have that many Puppet servers. One of the reasons why we do that is because we don't run Puppet every 30 minutes as the default. We run twice a day for an Ubuntu desktop, and then for laptops, typically when they join to the network, there's a DHCP hook that fires off a Puppet run. We're running it out of cron. We're currently running Puppet 2.7.3, but I'd say that in terms of the features we're using, we're still sitting somewhere around 0.2.5. But we've never really allowed old clients to hang around. When we rolled out the load balanced VIPs, that broke automatically all the Puppet 2.4 clients, so they went away very quickly. The transition to Puppet 2.6 took longer. We actually ran into some bugs, some scaling bugs with 2.5 that we just couldn't fix, and I finally just upgraded us and fixed everything, and it was wonderful. And then the 2.7 rollout was pushed by our Mac guys who wanted to roll out OS X Lion, and they claimed up and down that they needed 2.7 to do it. They said that the patching load, the backporting all the patches to Puppet 2.6 just wasn't going to be worth it to them. And so I want to talk a little bit now about how we lay out our core OS. We do not use nodes.pp. You can see our nodes.pp there. The core OSs provide one class, and then all of the intelligence in that class is done by subclasses. It turned out to be a lot easier for us to use fact information. What operating system is this? Is it a desktop? Is it a laptop? What configuration has the user requested? I'll get into that a little bit. And it was a lot easier for us to just use conditionals inside the base class to provide the core OS. And so the core OSs come in different flavors. We track them by release, which corresponds to the upstream release. And we track them by unstable, testing, and stable. So that provides the OS teams with places to do their builds, to do their testing, and to do canary releases. And then we also have roles, but generally only on the Linux machines, laptop, desktop, and server. The Mac guys used to have roles, but they don't use them anymore. The few Mac Pros that are floating around run exactly the same release as the laptops. And so I just wanted to give some examples of our environment names because I don't think that a lot of people with our Puppet deployments are making really heavy uses of environments, certainly not using them the way that we are. We have 40 or 50 different environments all told. And you can see how they're generated there. It's pretty basic and pretty boring, but it turns out to be incredibly powerful. The OS teams check into a common directory. You can think about it like head. We use perforce, so we talk about integrating between different directories. We don't talk about branching from head. And so they check into a common directory. It's one per OS, and then they promote it through the different tracks using an integration script. They do their acceptance testing on unstable. They do fairly extensive acceptance testing. And then they promote it to testing, and it sits there for a week, 10 days. The release schedules are totally up to the operating system teams. I don't care. They could release as often or as little as they want. And then they promote it to, after doing the acceptance testing on unstable, they promote it to the testing track, and then that's opt-in if you want to run, if you want to canary if you want to try out the latest release on your laptop or your desktop, or if you're a server owner who wants to canary the latest release before it gets deployed to your entire fleet of servers, then you sit on the testing track. And our OS teams, especially the Ubuntu team, have promised us that the testing track is going to be stable enough to be used in production. And in practice, even though it's not completely released yet, I haven't heard of a major failure as a result of somebody canarying their servers on testing. And it results in a very boring directory layout. It's not much to say about it. All this sits in the same part of the source code repository, and it's all wonderful and happy, and it works very well. So since the majority of our nodes, like 95% of them, are machines that users sit in front of one way or another, we had to provide some sort of customization for them, especially on the desktop machines where users can get, I'm sure everybody's heard about, the cliche about Googlers with the dual or quad 24-inch monitors. Well, we have to provide some sort of knob for the users to turn to control how those monitors are set up. Some people want to run them vertically, some people want to run them horizontally, some people say, oh, don't manage my Xconfig at all, I want to do it all myself. That's great. So we provide knobs for that. I'm going to talk a little bit about how we implement them. But back in the CF Engine days, we had a hack called No Touch, which was a little script that ran, and depending on what file it was, it either marked the file immutable, so CF Engine couldn't touch it, or added a No Touch file, which CF Engine would check for and then wouldn't touch the file. Puppet doesn't allow hacks like that. If you mark a file immutable, which people do all the time, then Puppet run breaks, and the desktop guys get mad because their broken machine count goes up. And we could do, adding a .no-touch file, it could probably be done with Puppet, but it seems like it would violate the very spirit of Puppet because you'd have to use execs and probably you do something like an only if, and no. So, as I said, our solution is to apply knobs. We use native data stores for this. We use a debconf database on Ubuntu, and we useplists on the Macs. And then the results are exposed as facts. I looked last night, and there are 64 total knobs covering all kinds of different things, from NFS configuration to which track of a given PPA are you going to sit on, to what resource limits like open files or how much memory a process can use. And this is an example of how it's done on Macs. Hopefully you can read that. You can write a value to a plist using a built-in Mac command, and then you can read it back. And this example here just enables Bluetooth. And then I've stripped out a bunch of stuff from the output, reading it back, but we store more than this in there. And then on the interface is a little bit nicer on the Ubuntu side. They've written some helper scripts to sit around it. So we've got this thing called Ubuntu config. Get it, Ubuntu, but it's Google, so Ubuntu. We have this Ubuntu config command, which if you run info, then it gives you the template value, which is provided by a package somewhere in the distribution. And then you can run a set and set the value to one of the accepted values. This particular example says, stop managing my video driver. I want to install the latest NVIDIA drivers and brick my machine, and it's my own fault. And then it will set the value and run Puppet, and then you can later go in and read it back and get the value. So as I mentioned, we run Puppet out of cron. The operating systems each implement a wrapper script around it. I'm going to talk a little bit about Ubuntu Updater because it's the only one I know anything about because I wrote parts of it. And its goal is to bootstrap the system enough to run Puppet. It takes care of all kinds of basically all the stuff that would typically go in a pre-run hook for Puppet, Ubuntu Updater takes care of. It makes sure that the required packages are installed, Puppet, Factor, some of the core packages that are provided by the Ubuntu team. Like there's the Ubuntu minimal package that provides most of the templates, for example. And then it runs things like apt-get auto-clean and apt-get-f install and dpackage-configure-a to make sure that the package database is in a clean state before trying to run Puppet. And it also checks for a big red button. We call it a central stop. But I was talking to Nigel, and he said that people get a better reaction out of calling a big red button. So we actually do have a big red button, and when something goes wrong, we can pause Puppet runs for, at least on the Ubuntu side, we can pause Puppet runs entirely, or we can pause them for particular rules. Like we can say, oh, we did a bad server push, so we can pause updates for just servers. I think they can also control it all the way down to individual offices or individual machines if they want to. And then the last thing that it does after running Puppet is it tracks the machine state. And we do not run Puppet Dashboard or anything like that. We run our own sort of dashboard application that's developed entirely in-house that meets most of the same functionality. It has a little clicky web UI where it's relatively easy to do basic operations like how many machines we have. I saw I watched the Puppet dashboard demo last night, and it's not one click. It's a couple of clicks and enter what you want to know, but it's still pretty simple. We can tell things like which machines are running version X of package Y, and which machines have failed their most recent Puppet run. And then it also has an API, which is really useful. One of the things that I've heard talked about a lot is auditing and compliance and letting your auditors run the same tools that you use. And this allows us to do that. They can run, our security team has a number of applications that they've developed against this database and are constantly filing bugs with the various operating system teams to upgrade vulnerable software. So, as I said, we used to have a single shared common directory. And that worked pretty well for a while. The original goal was the high and mighty goal of allowing the operating systems to benefit from each other's work. And in the beginning, that worked really well. But over time, the result fell short of the goal. My favorite example of what happened was with the SSHD config file. So the first problem that we had is each operating system had different requirements for this file. So we got a bunch of spaghetti code in the templates. So if you've ever seen spaghetti code in an ERB template, it's awful. You'd never want to go there. So then we switched to one copy of the template per operating system, and that was fine for a while. Although, I heard somebody else in this conference, I think it was the Facebook guy, say that he was embarrassed to be shipping multiple copies of, multiple copies of each of the same file with one little difference between each file, and that's kind of what we were doing. And then even that turned out to not be enough, because between the different knobs that the operating system supported, the different requirements for the operating systems, and just a number of different operating systems and roles, we wound up with the spaghetti code wound up moving out of the template and into the manifest, which was better, but it was still bad. And I really wanted to show an example of what the code looked like, but I couldn't fit the conditionals on the slide with the font size that's allowed by my presentation application, so I just didn't do it. Suffice it was really ugly. I'll just leave it at that. And so then they split up to one common directory per operating system, and it means that there are probably more lines of code overall, but the individual teams are able to work with it a lot more easily. As you can see, the Ubuntu and the Mac code bases have shrunk very dramatically, and that's mostly by removing, those are by line count, by the way. It's mostly because they were able to remove all the conditionals for the operating systems that weren't their own. We do still reuse code in a number of places where it works well, and different releases of the same operating system, going from Hardy to Lucid required almost no changes to the code base, for example. And then our desktop distribution is basically the server distribution with the GUI and the build tool slapped on top of it. So there's a lot of reuse there, and that works very well. And then there are some limited cases where we do class inheritance, where a class that's outside of the base class inherits some subclass of base, and that works pretty well in the few cases where it's required. And one of the reasons why we don't use class inheritance so much is because most of these classes were written 3, 4, 5 years ago, and they just weren't designed with that in mind originally, and it's a huge amount of work now to go back and change them. And just really quickly, I want to mention how we're deploying manifests, because I've seen it come up on the mailing list sometimes. We use cronjob. It just uses a Perforce client, checks them out to a temporary directory, and then rsyncs them over the production location. And in practice, this works great. I've seen a number of questions on the mailing list over time about what happens when the servers get out of sync. And in practice, that doesn't really happen to us very often. I can think of maybe 3 times total where I've had where someone has reported to me a Puppet backend that's out of sync, because we have a dashboard, and one of the things that's on there is the current change list number that each server is synced to, and when one of them's off, it's really easy. Its line goes straight, and everybody else is off to the right. And then we also have an alert to on-call, because this is actually kind of a big deal when it happens, and that's actually the reason why I find out about it, because the on-call guy calls me and complains about it. One of the things that we're doing now is we're using our NetScalers to pin clients to particular Puppet backends. So when a node connects, it all connects to its VIP that's been assigned to in DNS. It always connects to the same Puppet backend. And one of the nice side effects of that is if a backend does get out of date, it's not such of a big deal. Okay, you may get older manifests, but your Puppet run's not going to break because the manifests are out of sync between the two servers. We do make sure that time is in sync so that the cron job runs at approximately the right time. We do deploy a few IT services internally using Puppet. Not very many. Like I said, first of all, most of our Puppet nodes are not servers to begin with. And we have, Martin was talking about resistance to change in his presentation. And we've had a lot of resistance to deploying services with Puppet internally. I've been trying to champion a little bit, but there's a learning curve. And the solution that we have now, which is a piece of open source software called Slack, which is basically just a glorified wrapper around rsync. It's, you give it a directory of files, so install these on the server, and then you give it a pre-install and a post-install shell script, and off you go. And it turns out that that's been sufficient for many years to deploy IT services, and it's really easy. Everybody understands it because everybody understands directories full of files and rsync and shell scripts. So the add-ons also support tracks unstable, testing, and stable so that people can canary their services. We've made an administrative decision in our environments that the add-on track always matches the core OS track. That's just an administrative decision, and we did that to keep the number of environments down. There's absolutely no technical barrier to doing it, just nobody's asked for it. And that didn't come out as well as I'd like it to. But that is an example of the source file that we use to define our environments. Our Puppet.conf is generated. And you can see that each environment has a directory that it sits in. It has a corresponding add-on track. And it has a source environment. And the source environment is the place where when they integrate, when they're pushing code between tracks, there's a script that does it. It's called originally integrate.py. And integrate.py also uses the environment's YAML file to determine where it's going to pull the code from. And it's all very boring and very low tech. And it results in environment definitions that look like that in Puppet.conf. Obviously, those path names are relative so that it fit on the screen, but it works pretty well. We do run an external node classifier, and this is the way that server owners would apply the add-on modules to their services. We do have a proprietary database that maps services to servers. It's entirely internal and proprietary, and again, I can't say anything about it. But that's not how we originally deployed the external node classifier. We originally deployed it by using YAML files sitting in source control. And that turned out to be a perfectly good solution for something like 80 or 90% of our users. The reason why the 10% that didn't like it are the guys with 1,000 servers, and they didn't want to create 1,000 little YAML files, and who can blame them? So this is just an example. There's one or two files required to define a node. There's the node's YAML file itself, which can be named by the node's cert name. It can be named by the node's UUID. I think it can also be named by the node's MAC address. And the external node classifier knows under the hood how to go back into the fact cache on the Puppet server itself if you give it something other than the FQDN, or if you give it something other than the cert name. And it knows how to go through the fact cache and look up what it needs to know. If you're deploying thousands of servers and you want to apply the same configuration to each of them, we support include files, and that's what they're for. This example up here is for deploying our Puppet service. And then you get this sort of result when you run the external node classifier. The external node classifiers are really nice in that they're just standalone scripts that you can run, and then they output their configuration on standard out, so it's really useful for troubleshooting. So I do want to talk a little bit about our integration with the database. I mean, really, like most of our Puppet deployment, it's deliciously low tech. There's a script that runs on the CA that downloads all the information. It determines which services have Puppet integration turned on in the database, and then it downloads all the different, and then it checks all the different types of servers that are available. It checks to see if there's an include file for those servers, and off it goes. The Puppet masters themselves run a script that rsyncs this result off the CA, and then generates a set of node files just like the ones I showed you. And again, all very low tech. I don't recommend using live database queries for this sort of operation, any sort of operation like this. I always suggest get it on flat files, get it on disk locally, so that if your connection to the database goes down, then your service keeps running. We don't even, like I said, it's really low tech. We don't even use directory hashing. There are thousands of node definitions just sitting in one flat directory. And in practice, I would have expected that to be slow, but it turns out to work just fine. By far, the most expensive operation on the Puppet masters is still the catalog compilation. And we got the biggest performance boost in the external node classifier by we used to require Puppet at the top of it and then use Puppet's convenience methods for dealing with the facts. And that turned out to be really slow. We got a 30 times improvement by using the Ruby YAML libraries directly to work with the facts. Come on, you. All right. So one of the problems that we've had with being mostly physical hardware is that we need to provide a way to test changes before they're checked in. It's like I said, the Ubuntu team does their acceptance testing in unstable. So if you check something into unstable that's broken on a particular piece of physical hardware, you've broken the build. And nobody likes breaking the build. So we wanted to do something that allowed testing. And you can't use virtual machines because you can't test the latest NVIDIA driver on a virtual machine. You can't test wireless hardware on a virtual machine. There's all kinds of things you can't do on virtual machines, as useful as they are for testing. RAID controllers on servers, for example. So our solution is what we call ad hoc Puppet masters. And it's just a shell script. It runs a Webrick-based Puppet master as the user on the user's workstation out of their source control client. About 95% of the script is setup code. It sets up PPAs. It installs the necessary packages. It preps the file system. Almost everything is done in a temporary directory sitting in slant temp. Like that's where the puppet.conf lives. There are a few things that need to be symlinked from there into the user's home directory somewhere. It figures out where to symlink it to and does all the work. And then it fires up a Puppet master, and off you go. So one of the things that this does is it exposes all of the moving parts of the Puppet masters to the users. It exposes the external node classifier. It exposes the scripts that generate the node definitions. And so they can play around with them. They can play all kinds of what-if games. They can go and say, what would happen if I went into our service database and turned on Puppet integration? What would the result be? One of the biggest problems I would say that we have with the add-on modules is that when the external node classifier fails to classify a module or fails to add a module to a node, that failure is silent. And without something like an ad hoc Puppet master, there's absolutely nothing that the OS guys can do to debug this because they don't have access to the Puppet master servers themselves. This way, they can fire up an ad hoc Puppet master and they can run the external node classifier themselves, and it works exactly the same way that it will on the production machines. And it allows all kinds of other neat tricks too. They can remap there are convenient scripts to remap all the environments to the common directory. They can run, an unstable add-on track with a stable core OS, and all kinds of other neat tricks. The one thing that is kind of a caveat is that since the ad hoc Puppet master uses its own CA, you have to be a little bit careful if you're going to actually Puppet a production server against it. You can blow away the SSL certificate that's already there. So you just have to be a little bit careful. And the last thing that this gives us, since Puppet itself is deployed using Puppet, is it gives us a way to bootstrap the Puppet service from scratch. If there was some sort of strange disaster that managed to take out our Puppet infrastructure all the way around the world without completely taking out the entire company, then we could get our Puppet Masters back online by bootstrapping the first one using an ad hoc Puppet Master and then reinstalling the SSL certificates. And then we could bootstrap the rest of the infrastructure from there. And our operating systems are generally done, at least on the Ubuntu side, they're done using images, but we use Puppet to build the images. There's a script. The Ubuntu team has a script that runs debootstrap. It creates an Ubuntu chroot. It runs Puppet inside the chroot, and then there's a script that comes, and then the script comes along, tars up the image, uploads it to the TFTP server, uploads it to the web server that's serving it, and at installation time, the users can select either an image-based install or a traditional non-image-based install. And for the image-based installs, we've replaced the Ubuntu installer with our own thing that downloads the image, untars it. And then either way, after the core operating system is installed, there's a Puppet run, so the machine's brought up to date. And then the golden images are created every time they cut a release. It's part of their release process. So it's not like you're installing with an image that's 10 months old and then Puppet takes an hour to run and bring it up to date. It's the current thing. It's within a couple of weeks of being current. And I want to talk a little bit about some of the pre-commit hooks that we're using. These are four of the simplest ones. These are just really basic syntax checks on the files that we're using. I had originally hoped to show some of the actual pre-commit code that we're using, but it turns out that they're all written they're written in Python, which isn't the problem, but they're written in our internal Python unit testing framework, and it would be utterly meaningless to show it. So I'm just showing the commands that we're running under the hood. We're checking the syntax of Puppet itself, the ERB files, and of Ruby files that we're shipping. They're very basic, boring tests. We have some more complicated tests. We check to make sure that all of our file sources exist on disk, which is not the same thing as checked into Perforce. We've never updated it to catch files that people have sitting on disk but have forgotten to check in. So there's a little bit of a failure there. There are 4 regular expressions that do this, and if you're a regular expression geek, there you go. These regular expressions got so complicated that we had to mock out the pre-commit framework and write a pre-commit to make sure that they still work. But we check to make sure that Puppet URIs have 3 slashes in them. We check to make sure that we're using the new style syntax that has modules in it. We're checking to make sure that they're not empty. And then we're checking to make sure that we can actually extract a file portion from them. And you could do that. You could do all of this with just that bottom regular expression, but then the only error you could pass back to the user is, hey, this regular expression failed to parse. And that's not what we want to do. We want to be able to give more detail. And so moving on, you then take the file portion, and if there are variables in it, you just warn them. Don't pass on. You check and make sure that that the file is actually sitting in a module, and it turns out that the check for that is simple enough. You just make sure there's a single slash in the file portion. And then by looking at the directory that the file is sitting in, we can extract the environment, and then look, that's where the file should be. And then we also check that variables are defined. There are a couple more hairy regular expressions in this, not quite so hairy. And it's really pretty simple. We do have to make sure that they're not facts. So it turns out that we have static lists of facts defined. We have all the built-in facts in Factor defined in some static text file somewhere, and we have all of our built-in facts that we've written defined in another text file somewhere. And you'd think that wouldn't work very well, but it turns out that it does, because the fact lists don't change that often. There's some code that Nigel wrote before he left, I'm talking about Nigel now at Puppet Labs, that he wrote before he left that dynamically determines our custom facts, and I've looked at it and realized it would take about an hour or 2 of my work to implement it, and that it just wasn't worth it because nobody's complaining. And I want to close out a little bit by talking about style. These are just some tips and tricks that we've discovered over the years that work out pretty well. First, the Puppet symlink syntax can be confusing, especially if you use it in this form. And so I suggest using it in a more obvious case, where you're saying that you're ensuring it's a symlink, and then you point at an explicit target. And that second form is just much more readable. And here, you want to use resource defaults. Otherwise, you end up with code that looks like this. And it works fine, but some people really hate vertically expansive code. This makes the code too vertically expansive. It looks a lot better if you use a resource default. And you can use resource defaults globally by setting them in site.pp, or you can apply them on a class-by-class basis. They're really powerful, and you should always be using them. When you're doing requires, I do not suggest requiring a resource that lives in another class. And the reason why is it's kind of magic, because as you can see, package Puppet is defined in a different class than the service that's depending on it. But you have no way of knowing, just looking at that manifest, assuming these are two different manifest files, you have no way of knowing which file the resource is actually defined in. So what you should do instead is require the class containing the resource that you need. This doesn't work very well for things like it works for require, but I don't think it works for notify and subscribe. So if you're doing those, I really suggest making the resources live in the same manifest file, so it's less magic. Or using comments to tell yourself where to look, or it's not so bad if you're the only person writing the manifest and they're small and you understand everything. But when you start getting up to 10, 20, 30, 40,000 lines in hundreds or thousands of files, and you've got people coming in and out of your team, and there are different teams, then anything you can do to make the manifest more easy to read, more easy for a newbie to find what they need, you should do it. Or you can do, let's write this way. Or you can do it this way. You can just have the require happen at the class level rather than at the resource level. So this says that before any resource in class foo requires, or before class foo runs, then all of class bar needs to run. This turns out to be really useful in the add-on modules, where if they want their add-on module, where they want everything to run after base, then they can just say require base at the top of their add-on module, and it's wonderful. And this worked before there were run stages, and now that we have run stages, it's a little bit more conceptually easier for somebody who doesn't understand Puppet to understand. It's like, oh, okay. And then class inheritance, one of the mistakes that we find in our code base occasionally is that you inherit from a parent class without actually changing any resources in the parent class. And this is the same sort of magic that I was just talking about. In this case, class foo inherits, the class blah inherits class foo just so that it can get the require done. And this is kind of a contrived example, but we had plenty of code like this. And it works a lot better if you're actually changing a resource. It's like this one's fine. This is overriding a resource. And then finally, I want you to avoid magic variables. And this is a variable here that exists only to be used in that template. And it's kind of obvious here because this is, again, a contrived example. But when you're looking at a manifest file that's 10,000 lines long, and there's a variable at the top, and you don't know where it's used, and then other classes inherit from this class, for example, you can't figure out where the variable is used, and you're looking, and you're looking, and you're looking. It's not good. Again, it's just a minor pain point for smaller deployments, but as you grow, it adds to the frustration. And so I suggest the only thing you can really do about it is comment it and let yourself know, and you'll be a whole lot happier. And then the only other thing I want to say about templates is the absolute moment that you find yourself putting a conditional, any sort of conditional in your ERB template, stop. Stop right there and put the conditional in your manifest instead. You'll be a lot happier. And that's all I have. Any questions? Yeah?
Can you speak to the workflow a little of how you do signing for your new nodes?
the question I hope nobody would ask. We auto-sign. Yeah. Sorry, I don't have a good solution for you. With 2.7, this is all exposed to the API, and we could do something about it, but no, we're auto-signing. It's not so big of a deal because our company is almost entirely engineers, and almost all of those engineers have access to the manifest anyways, and we don't typically provision secrets like passwords or unencrypted SSL keys or things like that. So it's not that big of a deal. Yeah?
Do you use the Ruby DSL anywhere?
No.
Not at all?
No. At least not that I'm aware of. Like I said, I'm not living in the manifests anymore, so if they're doing anything weird and not telling me, that's fine. Yeah. Any more questions? Yeah.
Do you have a tendency to use default parameters classes for your modules? Like having a class that only has your defaults and then your main class?
Yeah. That's not typically used in the base class. I've done the Puppet add-on class that deploys the Puppet masters is done that way. All the various variable definitions live at the top level init.pp, and then they're populated on down.
What about parameters classes do you have?
Not using them yet. And actually, I think I'm out of time. Okay, thanks. I'm around for part of the day today. I have kind of an early flight, but I'm around. Please feel free to email me. I don't use the Twitters, so be old school and send me an email. Thanks.
Okay, we've got 10 minutes for a quick changeover, and then at 11 o'clock we've got